Okay, good afternoon. Good afternoon, class, and you're welcome to today's session. Today we're talking about system of quadratic and linear equations. From your previous lessons on system of inequalities and system of linear equations, we know that a system has two or more equations. Okay, so when you have a system, it means you have two or more equations. So what does it mean to have a system of quadratic and linear equation? It means that at least you have one quadratic equation and one linear equation. We know that quadratic equation is written in the form y equals ax squared plus bx plus c. So the purple stands for quadratic. And we know that a linear equation is given in the form y equals to mx plus c. Okay, I forgot to change the color, but that's okay. So linear. Okay, so it means that if I have two equations and one is quadratic equation and the other is linear equation, we know that every function has its own graph. Okay, so today's lesson, we want to focus on how to solve a system of quadratic and linear equation using graph. We know how a quadratic graph looks like. A quadratic graph, we said, is parabolic, and we know that a linear graph gives you a straight line. So let's go and apply. So if we want to find solutions using graph, right? All right. Then if I take a coordinate plane and let's say I draw a quadratic graph that opens upward. So this is my y, this is my x. So if I draw a quadratic graph that opens upward, let's take a quadratic graph like this. It opens upward like this, right? And then let's take a linear graph. That can be this way, that way, whichever way you want. Let's say the linear graph comes like this. Okay? We know from our system of equations that when you draw the graph of two equations, where they meet is their solution. So when you look at this, let's call this graph J1. J1. Okay. So when you look at this, you notice that they meet at 2 points. They meet here and they meet here. So we said that this system has two solutions. Has two solutions or two real number solutions. It has two real number solutions. Okay, so we can say that this system has two real number solutions. Now, what if we end up finding a graph like this, a graph that also looks like this? What if we get a graph that looks like this? Okay, let's say a quadratic is opening downwards. So it's opening downwards like this, right? And I mean, you know when a graph will open downwards and upward, when the A value, when the A value here is positive, it opens upward. When it's negative, it opens downward. I hope you remember. All right. So if we have this type of graph, and let's say this, and let's say this time the linear graph meets the quadratic graph at this point. Always name your axes, y and x. Then how many points do we have that they meet? They only meet here. So they have one meeting point. So we say that this system, G2, has one real number solution or one solution because they meet at only one point. So because they meet at only one point, the system has one real number solution, okay? So because they meet at, so when they meet at 2 points, the system has two real number solution. When they meet at 1 point, the system has one real number solution. So now, what if they don't meet at all? What happens if they don't meet at all? Let's say the quadratic graph is going to Ankara like this, and the linear graph is going to Gaziantep. So it's here like this. They don't meet. So if they don't meet, they don't share anything in common. So they don't have a common solution. So the system doesn't have a solution. Okay, so we say the system has no real number solution. Okay, so number one, G1. So this is G3. So G1, because the two graphs meet at 2 points, they have two real number solutions. G2, because they meet at 1 point, they have one real number solution. And G3, because they don't meet at all, they have no real number solution. Is that okay, guys? Okay, good. So if this is okay, let's go take an example. Let's go take an example, okay? Quickly. I want to use another screen. I want to change the screen to, okay, I think when I get there, I'll do it. So let's just use this for now, all right? Let's just use this for now. So for now, let's take an example. Let's say we have an example. Let me change the color. Example, so here we go. So let's say example. We have this quadratic equation, so x squared minus x minus 2, and we have this linear equation, minus x plus 2. Find the solution by graphing, okay? So we want to find the solution by graphing. We want to find the solution by graphing. So to find the solution by graphing, we first of all want to solve the quadratic solution. So solving the quadratic or graphing the quadratic. Let's do graphing the quadratic, it's better. So graphing the quadratic. All right, we know that to graph the quadratic, the easiest way is to find the axis of symmetry, find the y value, choose any other two numbers of x, and find the y value, right? So let's start by finding the value of x at the vertex or the turning point. So at the axis of symmetry, we know that x is defined as negative b divided by 2a, right? When you come to this question, the first one, y equals x squared minus x minus 2, what is a? We know that the only number that can multiply x squared and give you x squared is 1. So then our a is equal to 1. The only number that can multiply x and give you negative x is negative 1. So our b is negative 1, and our c is equal to negative 2. So to find x, it implies that x equals negative 1 divided by 2 into bracket 1. So you end up getting 1 over 2 If you forget your calculation how to multiply, then you know you are in big trouble. So try not to mess your multiplication up. Is that okay? All right. So now we have the value of x at the vertex. So let's go find the value of y at the vertex. Okay? So the value of y at the vertex at x equals 1 over 2. What is y? Then y becomes 1 over 2 squared minus 1 over 2 minus 2. Someone is saying, Mister, why are you getting all these numbers? Remember that the question is this. So wherever we see x, we put 1 over 2. Okay. So if we do this, then we will end up with 1 divided by 4 minus 1 divided by 2 minus 2. If you're not using calculator, you know that 2 is a factor of 4, right? So you can just use 4 and 1 minus 2 minus 8, which gives you negative 9 divided by 4. And if you want to use decimals, then you can say y equals negative 2.25. You can check with your calculator. All right. So it means that at the vertex, we have the coordinates 1 over 2 and negative 2.25. Okay, so at the vertex, we have 1 over 2 and negative 2.25. So now let's go take any two numbers of x. Let's go take any two numbers of x. All right? Any two numbers of x. So let's go take any two numbers of x. So let's say at x equals 0, then what will become of our y? Y becomes 0 squared minus 0 minus 2. So y equals negative 2. So we have 0, negative 2. And at x equals 1, then y becomes 1 squared minus 1 minus 2, right? So 1 minus 1, 0, then y equals negative 2. So we have 1, negative 2. You can cross-check and see if you get the same values or not. So now we have 3 points. And with 3 points, we know that we can draw the graph of the quadratic equation. All right, I want to use a graph sheet. So let's see, let me try and convert this into a graph sheet. Okay. I want to use a graph sheet. And if I stop share, I hope you have everything. So let me stop share and let's see. I want to use a graph sheet. Yeah, good. My graph sheet is here. All right. So I hope you can see. So now, we want to draw or plot, depending on where you're coming from. We want to plot the graph of the quadratic equation. Now, because it is a screen and my lines are close together, I'll pick each two line as one, okay? So this, we know the center is my 0, right? So I will jump 1. So here will be my 1, this will be my 2, this will be my 3, this will be my 4. So this will be my negative 1, negative 2, negative 3, negative 4, so negative 1, negative 2, negative 3, negative 3, negative 3, negative 4, negative 5. So I have my 1, my 2, my 3, my 4, and my 5. Okay. So let's plot the graph. At the vertex, we had 1 over 2, which is 0.5, right? And negative 2.25. So let's find that one first. Let's use the blue color. So 1 over 2. So then 1 over 2 will be here, right? So 1 over 2 will be on this line. So it means this is our axis of symmetry. This line divides the graph into 2 equal halves. Okay. And our x value is negative 2.5. Negative 2 is here, negative 5. So negative 2.5 will be here. So it means at this point, at this point, right? Anyway, we're using the screen. So at this point, the graph will turn. So that's the turning point of the graph. You already know this. We have done this in class. So I hope you'll be fine with it. So the next one was when x is 0, we got y to be negative 2, right? Where is it? When x was 0, we got y to be negative 2. And then when x was 1, we got y to be negative 2, right? Was it negative 2 or 2? Where is everyone? Okay, fine. Let's do it. Let's check. When x is 0, yeah, x is 0, y is 2. When x is 1, so x is 1, so y became 1 squared minus 1 minus 2. Okay, that's also negative 2. All right, so that's correct. So when x is 0, y is negative 2. When x is 0, y is negative 2. So that's down here like this. Color change, color. That's down here like this. And when x is 1, y is negative 2. So that's down here like this. Okay. Now you put are very close. So we can only get turning point and this curve. This is all we can get. But this is not a quadratic graph. This is just giving us the turning point. So we will add 2 more values of the x just so that we can plot the graph. So take any other 2 values. For example, if you take at x equals 2, then what is y? Y becomes 2 squared minus 2 minus 2, right? So that should be 4. Right or wrong? Okay, so that should be right. Then when we take the opposite of this number. So at x equals negative 2. Yeah, so that should be 0 rather. Yes, that's why I was checking. So it should be 0, not 4. Yep. So minus 4. So this is 0. So let's take the opposites. The opposite y equals negative 2 squared minus 2 minus 2. Then this cancels this. So we are left with y is equal to 4. Okay, right. Okay, so we have 2 extra points, which is 2 and 0, and negative 2 and 4. So let's go plot them. So when x is 2, y is 0. So when x is 2, y is 0, it means we get this. And when x is negative 2, y is positive 4. So that will come negative 2 up here, y positive 4 here. So that will be here. Okay, now we have enough points to plot the graph. So it means half of the graph will go like this, from here all the way like this. That's very steep. Okay, so something like this. Then the other half will also go like this. Okay, so now we have our graph for, we're using green, so let's use green. Our graph for y equals x squared minus x minus 2. So that's the green line. So now let's go and do for the linear, all right? Let's go do for the linear. So for the linear, the question is y equals negative x plus 2, I think. Yeah. So to draw a linear graph, we know you have to use the x-intercept and the y-intercept, the x-intercept, the y-intercept. So let's use that. So at y-intercept, we know x is equal to 0. So if I put x is equal to 0 here, then y becomes negative 0, which is 0, plus 2. So y equals 2. So I will have the coordinates 0 and 2, right? Then if I take at x-intercept, I know my y is equal to 0, right? So then I can say that y is equal to 0. So it becomes 0 equals negative x plus 2. So x equals 2. So here too we have the point 2 and 0. And you know that all you need to draw a linear graph are 2 coordinates. So we have 0 and 2, 2, and 0. So let's go back and back. Now let's put these 2 points on the graph. We have 0 and 2 and 2 and 0. So let's find 2 and 0. If x is 2, y is 0. They meet here. So the same point. Okay, and then if x is 0, y is 2. So that's up here. All right, so now let's try and draw a straight line. Now that's why I need a ruler. All right, I need a straight line. Need a straight line. No, this is a circle. This is a circle. This will not give me a straight line. No. No. Is there any other? Okay, I don't have a straight line here. So let's try and use our hand to draw a straight line. So if we're drawing a straight line, let's see if we'll get it. Let's see if we'll get it. Something like this. Yeah, I think it worked. Okay, now let's. So a straight line. Oh, nice. Don't do double line when you have a ruler. You will use a ruler and your pencil. So don't do a double line. I don't have a straight line on this screen. Okay, so now we have the yellow being our linear graph. Okay, so now we want the solution of the system. We said the solution of the system is where the graphs meet. So you can see that the graphs meet here and they meet here. So what's the point here? Here, x is 4, y is 4, sorry. X is negative 2. So we have negative 2 and 4. And here, x is 2, y is 0. So x is 2, y is 0. Okay, so now I can say that the solution of the system, right? Let's add S. So the solutions, because there are 2 in the system, are negative 2, 4, and 2 and 0. Okay, ta-da! So we have finished. So this is your solution for the system. I hope this helps you in your studies tonight, because tomorrow when you come to class, we are going to solve a lot of questions. Take care of yourselves, and I'll see you tomorrow.